purple shirt in the back, could I ask you to close like at least one of those doors so we don't have quite as much hallway track noise? Thank you. Welcome to JSON Web Tokens Will Improve Your Life. I'm John. I go by GeneHack most places online, Twitter, GitHub. So if you want to tweet about this talk and how bad it is, be sure to tag me so I can get the feedback. In my day job, I am the Vice President for Technology at a small custom software development tech consultancy training shop called Infinity Interactive. We're on Twitter at iInteractive. And this is my dog, Sammy. Sammy plays an important role in this talk. She's on Twitter too, at Sammy GeneHack. So I got promoted into this VP of Tech role a couple of years ago, and now instead of like writing code and doing cool stuff, I go to meetings, and then I write up notes in the wiki. So I don't do that much coding anymore. But when I do end up with a coding project, Sammy is kind of my pair-programmer helper from underneath my desk, which is where her bed is right there. All right, so what's a JWT or a JSON Web Token or a JOT? Who's heard of these before this talk? 5 or 6 people. All right, so anybody using them? 1 or 2 people, awesome. So if you wanted to find out what a JSON Web Token was, you might plug that into your favorite search engine, be it DuckDuckGo or Bing or Google or whatever, and you would probably end up in a website called jwt.io, which is a site that's set up by the people who invented these. And there you would learn, right here, that JSON Web Tokens are an open industry standard RFC 7519 method for representing claims securely between 2 parties. And you might come away from that description a little bit mystified, like Sammy was. Sammy suffers from a horrible condition known as resting stone face. Yeah, give generously, it's terrible. So you might at this point go, well, I need to figure this out, and they said RFC 7519, and so you might go look up RFC 7519 and try to read it, which I have done, which is how I know that the official pronunciation of JWT is JOT, because that happens to be spelled out in RFC 7519, that the way you pronounce JWT is JOT. It's a very confusing read the first time you read it, because there are a bunch of acronyms that aren't actually defined in this RFC. And reading RFCs in general is sort of an art, right? You have to know the specialized vocabulary and the way they use words like can and should and must. But this one was a little bit more opaque than normal. And it turns out that that's because it's not actually one RFC. You really need to read all 6 of these to fully understand the nature of JSON Web Tokens. So we have JSON Web Signatures, JSON Web Encryption, JSON Web Keys, JSON Web Algorithms, JSON Web Tokens, and my personal favorite, examples of protecting content using JSON Object Signing and Encryption, or JOSE. It's a lot of RFCs. Sammy was not too impressed with the RFCs. She's not real big on theory or reading. So having read most of these a few times, I can tell you that you can think of JSON Web Tokens as a lightweight alternative to cookies, kind of, sort of, that will also work with command line apps or mobile apps or even desktop apps. They don't have to be specific to the web. They function as an authorization or an access control mechanism in much the same way OAuth does, but you can use them without losing your local div, like happens if you have to implement OAuth. And they're also cross-domain friendly, so you can have a JSON Web Token be issued by one host and then give it to a second host, and those hosts can sort of depend on that JSON Web Token, and we'll see how that works. JSON Web Tokens are composed of stuff you probably already are familiar with and use. So they're just plain old JSON objects, or POJOs. So if you've done any kind of JavaScript programming, you've seen a JSON object. They're stringified, encoded, and cryptographically signed, and then usually transmitted over HTTP or HTTPS, but they don't have to be. The specification is actually completely agnostic as to how you transmit these things around. What do they look like? They're a simple dot-delimited string that has 3 parts. There's a header, a payload, and a signature. And we're going to break down each one of those parts in turn, but basically they just look like this. The XXX is the header, the YYY is the payload, and the ZZZ is the signature. So just 3 parts separated by dots. So we break those down and look at them in more detail. The header, again, it's just a plain old JSON object that then gets base 64 encoded, stringified in base 64 encoded. And the header typically contains metadata. Here is a key called ALG. That's the algorithm that's going to be used for signing the JSON Web Token. In this case, it's HMAC SHA-256. And then the type of token, this is a JSON Web Token. There are different types. I'm not going to talk about them too much, but you want to specify what the type of your key, of your token is in the header. And then you have the payload. This is the part you're actually interested in, the data that you're putting in the token. It's another base 64 stringified POJO. And it contains what the specification calls claims, which is fancy security talk for key value pairs, right? So it's just a JSON web object. And there are three types of keys that you can use in the payload. There are reserved keys, public keys, and private keys. Reserved keys are certain ones that are spelled out in the spec and are reserved for the use of the spec, such as this one, IAT. That's for an epoch timestamp of when this token was issued. Public keys, I don't have a good example of because the specification allows for a public key, which would be something that you would get published through an IANA specification for some sort of JSON Web Token you're using in a large public service where you want to reserve that key for your use. And then you have private keys, which are just the ones you make up and use within your application. You don't need to register them. And here we have name, Ohio Linux Best, and admin false. Those are both private keys, stuff we just made up, want to stick in this data structure and do something with. And then finally we have the signature, which is composed of the encoded header POJO plus the encoded payload POJO plus a secret plus that signing algorithm that we had in the algorithm key in the header. So a quick digression about my code samples. So I'm going to be showing a lot of code in this talk. Maybe too much code. Because I really wanted to drive home how simple and elegant these are to use and how easy they are to use. And showing you how they work on a code level is the easiest way to do that. In real practice, for most of the code that I'm showing, you would never write this code. There are libraries that already exist for this that are maintained by people who know what they are actually doing. And so you shouldn't use my code to generate JSON Web Tokens. For each code sample that I show, I'm going to show you the whole thing all at once. I don't expect you to read it. The point is just how few lines there are. But still 20 lines of code on a slide you won't be able to read. I'll go through and break it down into chunks. And then finally, in a few cases that I'm not going to necessarily point out, some error checking code or other stuff that you would want in real code has been removed from my code to make it easier to present. So don't just blindly copy and paste this and try to use it, please. Or if you do, I'm not responsible. So this is code in JavaScript to make a JSON Web Token. And again, the point here is not for you to read this, but just to look and see that's not that much code. Right? That's a very small amount of code. So if we step through this and break it down, we start off with a helper function that's going to take a JSON object and base 64 encode it. So we're going to stringify it, make a buffer, and turn that buffer to base 64 and then return it. Right? Some simple helper function to just convert a JSON object into base 64. We have a second helper function to generate an HMAC signature, which takes a string and a secret, and then it creates an HMAC thingy using the SHA-256 algorithm with the secret, sticks the string into it, and then generates a hex signature and returns it. Again, not too hard. Then we have the actual data, and this is the 2 bits from the previous slides. You've got the header specifying the algorithm and the type of token, and the payload with the name and the admin and the IAT headers. In real practice, of course, we want to get the current timestamp for the IAT header, not hard code a particular value. And then we have a secret. And now we're going to put those all together. Generate the signature, we're going to make the encoded header by base 64 encoding the header, the encoded payload by base 64 encoding the payload, and then we're going to generate the signature using that HMAC function. And the signature is just the header, a dot, the payload, and then the secret that's used to generate the signature. So now we have a header, a payload, and a signature, and we just concatenate those together with dots. And that's it. That's a completely valid JSON Web Token. If you take that JSON Web Token and do a little JavaScript magic to put in line breaks, it looks like that. And that's the actual, like I literally just ran that code to make this slide. That's what one looks like. That's the header, that's the payload, and that's the signature. Now, the critical bit of all of this, and the reason for doing it the way you're doing it, and the cool thing about these is, I can take that JSON Web Token that I just generated, and I can give it to you, and I can require that you give it back to me later. And I can tell you haven't messed with the contents of it, because if you had, the signature wouldn't validate anymore, right? So I can give this to somebody as part of a web transaction and require them to give it back to me when they want something from me, and I can then check the claims that are in it and be sure that they're actually the claims that I put in there. And that all depends on the signature. So I kind of poked a little fun at the JWT.io site earlier, but there is some useful stuff at JWT.io. One of the useful things that you probably can't read in that slide is where this red circle is. It says debugger there, and they have this web-based debugger for JSON Web Tokens where you can go and paste in your JSON Web Token. And this is the same JSON Web Token that was on the previous slide. You don't have to trust me because nobody probably wrote it down. But trust me, it's the same one, and it hopefully color codes the header and the payload and the signature. And then you can see over here, there's the decoded header, and that's exactly what we put in. And there's the decoded payload, and that's exactly what we put in. So this is really helpful when you're first using JSON Web Tokens, or when you're trying to get something to work and it can't quite work. Plug this in and make sure that what's in there is actually what you think you put in there. The other really useful thing on the JWT.io site, and again, you can't read the word inside that red circle, but it says libraries in there. They have a list of every JSON Web Token implementation for every language that they've been able to track. So there are JWT libraries for .NET, Python, Node, Java, JavaScript, Ruby, Go, Perl, PHP, Haskell, Rust, Lua, Scala, Clojure, Objective-C, Swift, and Delphi. Anybody using Delphi? Right? Anybody know who knows what Delphi was? Like half the crowd, all the young people are like, what's he talking about? So support, just general rule of thumb, if an open source project has support for Delphi, they probably have support for whatever it is you care about, unless it's like COBOL or something. All right, so at this point, Sammy kind of perked back up. We're past the RFC reading stage. We've seen kind of how simple and elegant the JWT spec is and how easy it is to make a JSON Web Token. So she started asking, like, how do I actually use these in my application? And one thing you can do with the JSON Web Token is sort of a basic authentication authorization type flow, much like a cookie, only slightly different. So I stole this image from the JWT.io site. You have a client server kind of thing here. The client comes in and hits an authentication endpoint /login or whatever, gives a username and password. The server validates that, and then generates and sends back a JSON Web Token. And now whenever the client wants to do something with the API, it sends that JSON Web Token back in with its request, much the same way that a cookie would, but not quite as automatically. And then the server can validate the signature on the token, extract the information back out of it, use that to generate the response, and send the response back. This is a fairly standard workflow. It's just you're using JSON Web Tokens instead of cookies. There are other ways to use it. We'll see later, because the specification is intentionally very, like I said, flexible and agnostic on how you move these things around. Yeah? Is there any protection for man-in-the-middle attacks? Thank you for the transition. So things that you should be aware of. The header and the payload are not encrypted, right? They're just base 64 encoded. Anybody can base 64 decode that and get back whatever you put in there, right? So just like a cookie, where somebody can read the contents of the cookie, don't put somebody's social security number in one of these, right? That's a bad idea. But it's perfectly fine to put like the row ID of the database table where you've stored their actual information, so that then when you get it back, you can get that ID, pull that row out, do your business. You do need to control expiration and reissue yourself, right? That's why there's that issued at header. Any JSON Web Token you generate for real will also have a key in it called EXP, which is the timestamp for when it expires. And you need to have a method within your API or whatever. If somebody has a token that's about to expire, they need to have a way where they can use that token to get a new fresh token with a longer lifetime. Questions?
So yeah, when I did my implementation, that was one thing I kind of got conflicting information on, like what kind of expiration time do you have, like days?
Right, what kind of expiration time should you have? And the answer to that is going to depend on your application. I don't think there's a hard and fast rule, and we'll see later one of the kind of, well, let me come back to that. It is a big question, it is something you need to think about. So some APIs I've seen will actually send back a fresh, different JSON Web Token with every response. So you get a token when you log in, but then on the next response you get, there's a different token, and they expect you to cycle that token on the client side. I think that's a little bit overkill, but again, it depends on your specific application. And the other thing to be aware of is that there's no sort of, unlike cookies, there's no control for what you do with this JSON Web Token on the client side. Site A can give you a JSON Web Token, and you can give that token back to Site B. And as long as Site A and B have shared the secret that was used for the signature, Site B can validate a token that was issued by Site A. Right? So this is nice. You do need to share that secret, but you can do sort of single sign-on, cross-domain style stuff with these. All right, so how do you actually throw these tokens around? It's up to you. For web programming, there are various things you can do. You can just serialize that token out and put it in a GET request. We'll see an example of that here in a little bit. You could put it in the post body just as a parameter. Or something that we do a lot is there's an authorization header that's part of the HTTP spec that's used for basic auth that supports various other schemes, one of which is called the bearer scheme. So you put in a header that looks like this, authorization, bearer, and then the token. And that just gets transmitted as part of the HTTP request. All right, so Sammy's impatient with theory. She wants to see some actual implementation code. So how would you actually use this? What does it really look like? So here's some Node code for generating a token, basically implementing an authentication endpoint. So again, that's not a whole lot of code. So let's step through that. So generating a token on login. This is an Express app, so the first thing we're going to do is declare a route. And this is how you declare a route in Express. You say /user/login is going to go to this user login function. And then we're going to load a helper library called JWT. This is something we use internally. It's a wrapper that we wrote around the Node module called JSON Web Token. If you're using JWTs in Node, I recommend JSON Web Token. We put a helper wrapper around it so that we can hard code some things like which algorithm we're using and the way we're doing secret management, so we don't have the secret strewn all around our code base and localized to one spot. So that's also a pattern that I recommend. And then we have the user login function. So the way Express routes work is you get past the request object and you get past a response object that you're expected to fill out. It's a fairly common web programming pattern. So the first thing we're going to do is say, does the request body have an email and a password parameter in it? This is a login endpoint. That's the two things we need is your username and password. If you don't have those, we're going to send you back a 400 error, and we're done. If we do have those, we're going to use the username to pull the user information out of the database. And we're going to make a claims variable. And if the password that we got, when we hash it, matches the hashed version that we have stored as part of the user, we're going to stick that user ID in that claims object. Otherwise, if the password doesn't validate, we're going to throw a 401 error and tell you need to log in, you screwed it up, we're done. Otherwise, we're going to sign those claims, and this is, again, is just a helper function. It's going to generate a JSON Web Token using a secret that's embedded inside that JWT library. And we're going to take that token, we're going to stick it in a special application header that we have defined and documented in our API, and we're going to return that along with a 200. And now the client will pull that token back out, and the next time they want to make a request to this API, they'll send the token back with it. All right, so you're making one. It's good. How do you validate it? What does that look like? So this is Express. We're going to use a middleware for that. I'll explain what that is here in a minute. Again, this is not a whole lot of code. Breaking this down. So we're going to load up that JWT helper library again. And then this is the way you define a middleware in Express. People know what a middleware is. So if you're doing web programming in an HTTP stack, basically middleware is a piece of code that you inject into the response cycle that gets control before the actual thing on the endpoint. So this is going to run on every request before any other downstream code happens, and it will have the ability to modify the request or reject the request and just stop processing. So this is a perfect way to check whether somebody is logged in or authenticated. So this is how you define a middleware in Express. You call app.use with a callback, and that callback expects to get the request, the response, and a callback function for the next step in the middleware pipeline. So if everything works right, you're going to call that next function, and things are going to keep rolling down. But if you want to, you can also bail out of the response cycle at this point and just return a response. So first thing we're going to do is make a place in the request object to hold the decoded JSON Web Token and the optimistic hope that that's going to work. And then we're going to do some promise stuff that's slightly difficult to explain. But what we're going to do here is get the authentication header out of the request. And then once we have it, we're going to pass it into this function. That function is going to make sure that there was a value in that authentication header. And it's going to break it into two pieces based on a string. And it's going to make sure that the first piece is bare. Because there are other schemes that you can find in that authorization header. And all we want to deal with is the bare scheme. So if it is bare, then we're going to call the verify function in our helper library and give it the token. If it doesn't validate, we're going to throw an exception. And if we don't have an authorization header at all, we're going to throw an exception. And then we're going to chain another function onto this, because if the validation does work, we're going to just return the value of the validation, which is the decoded JSON claim object from the JSON Web Token. So if that works, we call this next function in the chain, pass it that payload. It sticks the payload into that JWT slot on the request object, calls the next function in the middleware chain, and we go on our merry way because the token validated, and we're just going to keep processing the request. However, if we threw one of those exceptions, we have a catch block at the end of the promise, we're going to grab that error, and here's the hole, right? Anytime you have an authentication system, you can't require authentication for every endpoint because you have to have one endpoint to become authenticated, right? So we check here to say, oh, was this request for the user login endpoint? If it was, that one you can get to. So we will go ahead and call the next function. We require you to be posting, right? Because get user login doesn't make any sense. We certainly don't want somebody putting their username and password in the query string. Otherwise, if there's any sort of other error function, we throw a 401 to say you need to authenticate, and we're done. This causes the request to be sent back, and the rest of the middleware chain doesn't work. And again, you want to log that. There's stuff that's not in here. Right? So that's cool. That's pretty simple. Kind of recapitulates cookies. Sammy's like, all right, I'm happy. I might use JSON Web Tokens in my next coding project. Treat requester. What else? Yeah, what else can JSON Web Tokens do? One thing that we've done very successfully with an application at work is what we call pre-signed content requests. So the scenario is we have an application, it's a web-based application that stores documents for people. It's a client-side Angular app. It uses JSON Web Tokens for authentication and session management, and it uses the authorization bearer scheme for that. But this is a document store. We want to display, some of those documents are JPEGs. If somebody's looking at their documents, we want to show them like a thumbnail image of the JPEG. So how do you do that? How do you display or download images via the browser when you're requiring every endpoint to be authenticated, and all the browser is going to see is an image link with a source attribute, and it's not going to send a special HTTP header, it's just going to send a normal HTTP request because it's just a web browser. It knows nothing of your JSON Web Tokens. So what's the solution? It's JSON Web Tokens, of course. You're going to talk about JSON Web Tokens, like, duh. So what we do is we generate a claim that contains the document ID. So we have an issued at header and expiration header and the document ID that corresponds to the row in the database where the document stuff is stored. And if you look at these expiration, or issued at and expiration headers carefully, you can see it's only valid for 60 seconds. It's got an extremely short lifetime because basically we're going to create the code, the HTML code for the page that we're going to display that's going to have all these thumbnail documents in it. That's going to get loaded in the web browser, and as the web browser is processing it, it's going to make these image source requests rapidly. So this doesn't need to be a long-lived token. We sign that token and we just embed it in the URL. And this is literally what it looks like, /content/JSON web token. On the server side, when we get a request that looks like this, we have a route defined for a GET request to /content wildcard. And we pull that JSON web token out of the wildcard match, we validate it, extract the document ID out of the payload, get that document from the database, and send it back. So Sammy was impressed by that one. You guys take a picture of that, that's good. All right, so what else can you do? So that's an example of how you can encode that token and just send it in a GET request, right? It doesn't have to be in this header. Yeah.
So how did the client sign the JSON web token to send back?
The client didn't sign the JSON web token. We generated server side.
So you send it to the client.
Send it to the client in the HTML.
Okay.
Right, that it's going to render and display, and then as it's going, oh, this is an image link, I need to fetch the image. It hits that URL just like GET request.
I think also, like my implementation, I use Angular, and Angular has, I can't remember exactly what's called, interceptors.
Yes.
And I use an interceptor to process every request, and if it met a certain path, I would attach the token to the request.
That's a good solution too. Do you remember when those came in? This is an Angular.
Interceptors? This is Angular 1 app.
Okay, yeah, this is Angular 1 too.
Yeah.
There may be other ways to shape this, yeah.
Sure.
All right. So another problem that I have, and this was actually kind of one of the inspirations for giving this talk. I feel like I've been doing web programming for, let's say, more than 15 years and leave it at that. And I feel like I've run into this problem over and over again, and JSON Web Tokens have given me sort of the first solution to this that I actually don't hate. And that recurring element is some form of lightweight access control. So you're making an API or something that you're going to put on the web, and you don't want the whole internet to see it, right? So you have three options. One, you can leave it wide open, which you call the MongoDB pattern. I don't recommend that. You can write a full authentication subsystem again, right, and deal with things like self-service password reset and an admin page to manage users and blah, 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 blah. Who's written more than one of those? Yeah. Who wants to write another one? Right? Okay. Or you can use something like OAuth, which, who's used OAuth? Who's liked using OAuth? I had one person leave their hand up once, and I was like, or you can go to even something heavyweight like SAML. Who's used SAML? Who wants to never hear that word ever again? Yeah, SAML is awful. Okay, so where's the middle ground, right? Where's the middle ground between the bank vault approach and the completely wide open door approach? Like, I want a screen door, okay? I want something that'll keep the bugs out, but is not going to survive somebody with like a determined intent to get inside, because I don't really care that much, right? I just want to not have annoying people knocking my stuff down. So, repeat. You have an API, you don't want to make anybody authenticated to use it, but you don't want to leave it wide open to the internet either. You basically want authorization without authentication. So what you can do with JSON Web Tokens, there's a way in the spec, it's spelled out, where instead of using a single secret, you can use an RSA key pair as the secret. And you can include, so basically you sign things with the private half of the key pair. And there's a special defined header where you can include the public half of the key pair in the JSON Web Token. It's called JWK, which stands for JSON Web Key. So this allows you to generate tokens client side and send them in, and then verify them server side. So to set it up, you call up your authorized API client or exchange email, or you can even write a website to do this, and give them or have them generate an RSA key pair. And you keep track of the fingerprint of the public key. That's going to become important in about 2 slides. You need the fingerprint of the public key to make this work. But the client can generate the key pair themselves. They just need to tell you the fingerprint. On the client side, they generate a JSON Web Token that contains the public half in the header that's defined for it, and it's public. There's no problem with this. You're expected to share the public half of the key pair. They sign the JSON Web Token with the private half. They have to include issued at and expired claims, and they send the JSON Web Token in with their API request in the bear header or wherever. On the API side, you get the JSON Web Token, you extract the public key, you validate the signature using that public key half, right, which will only work if the key was signed with the corresponding private half. And then you validate that that public key fingerprint is on your whitelist of allowed public key fingerprints that you maintain. If the public key is whitelisted and the key validates, we know that the person who made the JSON Web Token is authorized to use the API. Right? Now, the fingerprint part is really critical because if you don't check the fingerprint against a whitelist of known fingerprints, any RSA key pair will pass through this, right? So checking that fingerprint is really kind of important. You still also need to validate the issued at and the expired claims, any other rules you have in your API. If you've picked a good library for this, it should do most of this for you. Yes?
2013 is not that far away. Is the expired at also seconds since Unix? epoch?
Yes. Yeah, they're all Unix epoch seconds. 2032, not 2013, right?
2034 I thought was.
2034. This is
January 17th at 2 in the morning.
This has been Unix trivia. And again, with this, right, despite the fact that you're using an RSA key pair, there's nothing encrypted, right? It's still trivial to get the stuff back out of the header and the payload, so you still shouldn't put social security numbers in there. Sammy is impatient to see code again. So here's the client-side code. This happens to be in Perl instead of Node because the project that I wrote this for was a Perl project. But don't be scared. I'll walk you through it. It's extremely readable, I promise. It's not scary. So we're going to load up some libraries. There's a Perl library called cryptjwt that's used for encoding and decoding JSON Web Tokens. There's an RSA library, and then we're going to have an HTTP request library. We're going to read our public and private keys off of the file system in the things not to do category. Not storing your keys in files in the same directory as your application is kind of in the middle, so don't copy that. And then we're going to generate a token. Here we're using a different algorithm. This is RSA SHA-512. We're going to include an extra header in this JW key slot, which is the public key exported in JWK format. And then we're going to use the private key to sign it. Our payload is just going to be the issued at and the current time. And the Perl JWT library has this cool relative expression thing where you can say, I want an expiration header that's this many seconds after the issued at header. So this is going to last for half an hour. And then we make an HTTP request to our endpoint, include that in the authorization header, and we just encode a JSON body to the request. So the really critical bit to this is adding the public key to the header. The JSON web key format is I can't say it's not standard because there's an RFC for it, but it's not a normal like PEM type format. A bunch of libraries don't support it. It took me about 8 hours total. Like there was one coding day involved in getting all of this to work, and about 4 hours of it was figuring out those like 2 lines to get the JSON web key exported in the right format. So find a library that supports that. It'll make this a lot easier. On the API side, again, not a whole lot of code. First thing we're going to do is get the token. So we're going to load up that same JWT library, our RSA library, a web framework called Dancer, which is a Perl port of Sinatra. If anybody's familiar with Sinatra, it's just a micro web framework, and an exception handling library. We're going to pull that authorization header out of the request headers. and then we're going to define a key to, or a variable to hold the token, and we're going to return a 401 unless, and what we're doing here is taking the authorization header and matching it against a regular expression for bearer and then anything to the end of the line. So I'm sorry, I'm a Perl guy. If I don't include at least one regular expression, I get kicked out of the club. So this is it. So what we're doing here is taking the authorization header, finding everything after bearer to the end of the line, and sticking it into $token. And if we can't do that, that regular expression doesn't match, we just return a 401 error.
Tiny dancer, really?
I didn't make it up. So then we're going to try to decode it and confirm that it's valid and validate the issued at and expiration claims. So we're going to make a header and payload variables, and then this try block is going to use the decode JWT function from the library. We're going to give it the token, we're going to ask it to decode the header, we're going to tell it that the RSA SHA-512 algorithm is the only one that works, and we're going to ask it to verify the issued at and expiration claims. So if you give me a token that was issued in the future, this will fail. If you give me a token that has an expiration time before the issue time, this will fail. If you give me a token that's expired, this will fail. If you give me a token that wasn't using RSA SHA-512, this will fail. And if the token itself doesn't validate, this will fail. Any of those failures will throw an exception, but we don't catch that exception because the other thing they will do is not populate the header and payload variables. So we just return 401 unless we got a header and a payload. So if we get down underneath this 401 line, we've got a header, we've got a payload, the token was valid. Right? So just to recapitulate that, if the key in the header is wrong, it fails. If it's not the right algorithm, it fails. If it doesn't have those claims or if they're bogus, it fails. And all of that validation happens within that library, and I don't have to deal with it. So I win. You do need to do a few more checks that I do show the code here in a second. So we specify in our APA documentation that you shall not generate a JSON Web Token with more than a 30-minute expiration, more than a 30-minute lifetime. So I need to make sure that that is true, because I don't want people generating tokens that live forever, right? And I also need to make sure that this isn't some random key pair, that it's on my whitelist. So the first thing I do is check that the expiration time, sorry, I lied. The API docs say less than 1 hour. So I check to make sure the expiration time minus the issued at time is less than 3600. And then I check that the included public key is in my whitelist. So here I'm going to generate an RSA key object. I'm going to stick the header JWK key into it, and then I'm going to generate a thumbprint and make sure that that thumbprint is in my whitelist.
That looks like it's subject to a replay attack. You're not validating that IAT is current.
That happens at the library level.
Okay.
It is subject to a replay attack if somebody gets the token before it expires and uses it again, but I don't care. So that's it. We know the public key in the header is by the fingerprint, so we know that the private key was used to sign it or to validate, and therefore this JSON Web Token came from the private key holder, who by definition is allowed to use the API. This whole thing depends on the person who has the private key keeping the private key private. It's right there in the name. But revoking a key is as simple as removing the corresponding public key fingerprint from the whitelist. Depending on how your server works, you might not even have to restart your server. So yeah, and as the gentleman in the front row pointed out, this is subject to a replay attack. But that's fine, because it's a screen door, right? If you walk away from your house and the only thing you have between it and the outside is a screen door and somebody has a pocket knife, you're subject to a pocket knife attack, right? So it's a matter of deciding what risk profile is acceptable to you. The API that we were trying to protect was extremely low value, and we basically wanted to keep out flies, right? Which is why the screen door approaches that. If you're protecting something that is more secure, yes, you should consider things like replay attacks. But for this, for a token that lives for 30 minutes that's required to be transmitted over HTTPS, I'm not too worried about it. There are some more advanced usages of JSON Web Tokens possible. So you can encrypt the payloads. That's called JSON Web Encryption. I haven't read enough of that RFC to understand it to a point where I can explain it because it kind of made my head hurt. Another thing that made my head hurt was the notion of nested JSON Web Tokens, where you have a JSON Web Token that contains another JSON Web Token. Typically, that is used where the external one would be unencrypted, but it would include an encrypted one, or vice versa. If you're interested in either one of those, I recommend that you read those RFCs. And finally, this is Sammy's friend Pepper. Pepper is a Chinese crested, which is popularly known as the ugliest dog breed in the world. Sometimes called, oh my God, what's wrong with that dog? But no, they're just supposed to look like that. I would be remiss if I did not tell you that some people are not fans of JSON Web Tokens. I hope at this point you understand that I am a fan of JSON Web Tokens. But it's not that hard if you look on the web to find articles with titles like "Don't ever use JSON Web Tokens ever, ever," or "JSON Web Tokens will ruin your life." And the objections to JSON Web Tokens fall into one of two categories. Category number one is based on the fact that the original RFC had a fairly glaring bug in it. One of the acceptable algorithm types, and in fact, one of the two algorithm types that libraries are required to implement is called none. The other one is HMAC SHA-256. The none algorithm basically says, hey, there is no signature. So if I generate a JSON Web Token with the none header and give it to you, a library basically just doesn't try to validate the signature, which is kind of bad. And it turns out that if you're depending on the value of the header in a JSON Web Token you got from someone who you don't trust, they can edit what's in the header and change that algorithm to none. And if you have one of these buggy libraries, it will tell you that key is still valid. This has been fixed. This was found in 2015. Pretty much every major library, and I think this is tracked on the JWT library list, has been updated so that if you have a signature with a none algorithm but still has a signature, it won't validate. Any code that you are using, you should specify an acceptable list of algorithms, like I did in my Perl example, and you should not basically don't blindly trust the algorithm that's in the header. That fixes that problem, but there are some people who have taken the attitude of, well, they screwed that up really big, we can't trust anything they've ever done, which, whatever. The second objection is that the spec in general is too flexible and has too many options. I'm a Perl guy. This is not an argument that is going to win me over, ever. So, make your own choices. Personally, I think the JSON Web Tokens solve some fairly common problems in a pretty elegant and simple and easy to understand way. I might go off. And this is pretty cool, and that you should maybe think about using them. All right, so I'll take questions here in a minute. I want to thank the JWT.io people and auth0.com, who's an identity provider as a service company that originally came up with JSON Web Tokens. And I want to thank the organizers for accepting the talk. I want to thank all of you for coming to the talk and asking good questions. And I want to thank my company for paying to send me here. We're pretty cool, and if you need any custom software developed or technology consulted upon, come talk to me and I'll give you a card. And I'm happy to take